Assalamualaikum and good morning. Okay, today we will present our project on subject Digital Logic Design Lab, code BTE 3222. Our title of project is Car Security System. Okay, my name is Faris Aiman bin Mohamad. My ID number is TB19021.
My name is AMEERUL bin ISHAK. My metric number is TB19031.
Okay, my name is Mohamad IRFAN. ID number TB19007.
Okay, first I will explain about the interaction of between our member. Okay, on Thursday 27th May, our project task of Digital Logic Design Lab was given by Sir. Okay, on the next day, we have a meeting via Google Meet to discuss our topic and give the task distribution. In our meeting, we have decided to choose the car alarm system design for our topic for this project. That apply of the topic that we have learned before. This, which are the combinational logic circuit, which is D flip-flop and others. Okay, for the task given, I am is a leader that take in charge for the table implementation and the result. And I also compile of this report. Okay, next, Ahmad that take in charge for the introduction and conclusion. Okay, for next our member is Irfan that take part in the simulation for this circuit design by using the Proteus. Okay. We take about 10 days to complete our report successfully. And today we have a presentation for our report. Okay, next I will pass to Ahmad to present.
Okay, Assalamualaikum. Okay, for my part, for the problem description under introduction, for our project, we will make the car alarm in the Proteus with the combination of the logic gate by using combinational logic circuit, which is AND gate and OR gate. The issue with a combinational circuit is that once the alarm is activated, such as by opening the door, the alert may be shut off instantly by shutting the door. However, once the alarm has been activated, it should stay on long after the door has been closed. And the only way to turn it off is to turn off the master switch. This necessitates the use of a sequential circuit in which the output is determined not only by the present input switch settings, but also by the alarm's current state. Okay.
Okay. After we have looked the problem description, and we can continue about this table. We have three input, which is S as a main switch, M as the motion sensor, and D as a door sensor, and output A, which is a car alarm. Okay. From this table, we can have if the switch and door is high, the output is high, and which the switch and sensor is high, the output also high, and all the switch, motion sensor and the sensor are high, the output will also high. Okay, from this table, we can express the Boolean expression, which is A equal to D M naught S plus D naught MS plus DMS. Okay, from this Boolean, we can simplify by using a few techniques, and we also get the simplified the equation, which is A equal to SD plus SM. Okay, next we will see the next state table. It has the present state and in 3 inputs, which is S, M, D, and the next state Q net. Okay, before this, we will see the lecture notes. Okay, for the present state and next state is low. The output input of the D flip flop are so low, and is 0 1. Is the output is 1 1 0 is 0 1 1 is 1. Okay, we can see if the present state Q is 0 1, the next state Q next is 0. The 1 1, the next Q net is 1. Okay, next, for the implementation table, it is the same as the next table, but the next state Q net will replace with the flip flop input, which is D naught. We can see for this implementation table. Okay, next, for the K-map, we take the value from this implementation table, and we fill this table, and we grouping the value of 1, and from this we can minimize equation, which is D naught equal to SD plus SM plus Q naught S. Okay, I will pass to the IRFAN to present the simulation of the circuit.
Okay. For the component and method, so for the circuit we have VCC, a clock, AND gate, OR gate, D flip flop, logic probe, and logic state in as we use in the Proteus software. So for the method for the project, okay. So first we state the problem description and do the draft for the circuit diagram. So once the alarm has been activated, it should stay on long after the door has been closed, and the only way it turn off to master switch. So this necessitates the use of the sequential circuit, not only by present input switch settings but also the alarm current state. So after we build AHMAD make table, so we make the simulation of the circuit. So for the simulation of the project, so we build a circuit according to the Boolean expression from the AHMAD. So as you can see here, there are 3 AND gates, 1 OR gate, a D flip-flop, and a clock. So as you can see here, when the input are 0 on 3 inputs, also the alarm will stay at 0. So as example, when we activated input of D, so it will stay at 0. So when we open S and D, it will stay 0. It will turn into 1 as the alarm is turned on. So next is it is same when S, M, and the input are open. The alarm will turn on. So when S input are turned off, the alarm will turn into 0. So same as when D is in when only one input are there, so the output will stay at 0. Okay, as you can see here, if only one input are high, so the alarm will stay off. Okay, so the circuit the output of circuit follow exactly as the implementation table, as we build the circuit according to the implementation table.
Yeah.
So for the discussion of the project, so as you can see earlier, the circuit has been designed by using purchase software, and then to obtain the result, we simulate the software, and as I said earlier, the result from simulation is recorded and result follows the implementation table. So to build a car security system, it was enough to build to use a combinational circuit consists of 2 AND gate and 1 OR gate. But the problem is when the alarm is triggered, so the alarm will close after the closing of the door, but it is not convenient for the customer or for the user to use the alarm. So we add some additional components such as D flip-flops and 1 additional AND gate to the circuit. So the flip-flop is the D flip-flop is the most important flip-flop from other clock types. So it ensures that at the same time both the inputs are never equal to 1. So it is important to have D flip-flops in the circuit to ensure the alarm is still on after the closing of the door. So for any problems or errors, we don't encounter any problem and errors because we mostly use the simulation as to build the circuit, so we can avoid human errors or any systematic errors from the designing of the circuit. Okay, thank you.
Okay, for my part is conclusion. Okay, in conclusion, the outcome of our project is we will get the security system in which the alarm will turn on for any intruders and will still functioning even after the door has been closed. The alarm can only turn off after pressing the main switch. However, the addition of the flip-flop and AND gate in the end of existing circuit can solve the problem. This is because the D flip-flop is the flip-flop from other clock types. It will ensure the alarm is still on after the closing of the door. In the end, we did not counter any major problem on making the circuit and run it because we use the Proteus. Okay.
Okay, next, this is our reference, and this is our appendix. Okay, that's all from our presentation for today. Okay, thank you.